choosing product mix to maximize profit. When we have multiple products and the process that has to produce them or process them, we can find flow rates for all products through optimization. For example, optimization that maximizes a total profit achieved per unit of time. Consider this example. Blue Ridge is a company that produces hot tubs, and they have two types of products now that they are considering, aqua spas and hydroluxes, that they want to produce in such a way that they maximize the total profit that they obtain per week. Now, in this table, you see all the resource requirements and the three resources that are used are pumps, labor, and tubing, and you can think about them as the resources that limit the production. They can only have 200 pumps per week, and this is right because the supplier is limiting this input, or the tubing, they can only have so many feet of tubing, and they have certain requirements. They also have a limited capacity of one step, which is labor, right? They only have so many workers that can provide 1,566 labor hours per week, and each product requires a number of hours. We also know some kind of profit contribution for each product, and we also know the demands. So this problem can be formulated as an optimization problem. This is actually part of a decision-making course. This optimization problem has two decision variables, right? Because we have two products. X1 denotes the number of aqua spas that we want to produce per week. X2, number of hydroluxes. And you see, we actually are not going to adjust those values manually and then control for implied utilization. You could actually find out that implied utilization on most of those resources, probably on both of those, on all three of those inputs or the resource would be higher than 1. So we're not going to choose manually the levels of production. We will actually ask some kind of algorithm, optimization algorithm, to solve this for us. We just formulate this as an optimization problem. We say maximize this total profit, which is calculating, taking this profit contributions multiplied by the number of units that will be produced per week, and this will calculate the total profit in dollars per week. This is going to take care of the pumps. We say total number of pumps, one pump for every product. The total number per week cannot exceed 200 that is available per week. And you see here the 1 and 1 that is used. And then we calculate labor hours the same way. We use 9 labor hours and 6 labor hours for the respective products. And this is the total available. So 9 times X1 and 6 times X2 must not exceed 1566. Similar constraint for tubing. How much is used, not more than available. And we have some logical constraints like limiting the level of production to the demand. We should not produce more than demand for aqua spas and for hydroluxes, and we also have non-negativities. Negative number doesn't make sense. So this problem can be solved in Excel in a simple model. We can say our variables are somewhere here, right? We don't know what the values will be. I can enter some example values, for example, 1 and 2. Just to see how the formulas will be calculated. Then I will have the profit, right? And remember, profit were 350, the contributions were 350 and 300. So I can say, here I can calculate the total profit as a sum product. This is just implementing the functions. All right, sum product of those two arrays, which will calculate 350 times the value for X1 and 300 times the value for X2. Right, so this is calculating 950 as a total profit, and then I will have the constraints, which were about pumps, labor, and tubing, right? And the consumptions were 1 and 1 pump, 9 and 6 labor hours, and then 12 and 16 feet of tubing. Then the total used can be calculated using the same function provided to use the dollars here, right? So this uses 3 pumps, 21 labor hours, and 44 feet of tubing. And then I can also say available units. Available units were 200, 1566, and 2880 for their respective inputs or resources. And I will actually also insert here, let me insert one more line, and I'll say demand. And demands were 150 and 140. And this is what basically defines my optimization problem, the formulas. Now, if you want to optimize this in Excel, there is an Excel add-in, but it's normally available under data, except that it has to be enabled. To enable it, you have to go to File, Options, then find Add-ins here on the left, then click Go here, and then enable Solver add-in. When you do this, in the Data tab, you will see Solver appearing here to the right, and then in the Solver, what you have to do is, in the Solver window, you have to say, maximize the objective, which is indicated here, which we calculated as total profit, by changing the decision variables, the flow rates, X1 and X2, number of aquaspas and hydroluxes to make per week, subject to all the constraints. And the constraints are the pumps, labor, and tubing that are used should not exceed the available units. The demands, the number of produced units cannot exceed the demands. And then we can say unconstrained variables should be non-negative, which will take care of the variables not being negative ever, right? Not being allowed. I'll also choose simplex LP because this is a linear programming model. And if you solve this, hopefully I have a correct model. It says solver found a solution, optimality conditions are satisfied, and I will keep the solution, and I will actually be able to see the optimal plan is to produce 122 aquaspas and 78 hydroluxes. That gives me maximum possible profit. There is no way to increase the profit above $66,100. This is the maximum possible. And if you look at these resources, you will see that actually all the pumps are used. So this is a constraint that is limiting the production. All the labor hours are used. This is a constraint that is limiting the production. But you see, tubing is actually not used to the limit. So this is not actually a constraint that limits the production. What I want you to see is if I put here 150 and 140, right, the demands on pumps, labor, and tubing would all exceed the available units. And if you like, if I were to calculate implied utilization as what is demanded divided what is available, right, all of them have implied utilizations more than one, right? However, when we solve this problem to optimality, let me solve it once again, right? When we found the solution 122 and 78, you see that now, of course, this is no longer implied utilization, this is now utilization, right? The utilization of for pumps and labor constraints are 1, but for tubing, it's 94%, right? So this is 100%, this is 94%. So that means tubing is actually not used to the limit. And in fact, it is not constraining our production because the other constraints ended up more restrictive given how much profit each product brings. So here you see that again, profits affect which constraints are actually are limiting the flow rates. So this concludes the segment where we're trying to choose the product mix that will maximize profit, and this is another way of choosing of analyzing a process and finding out what the flow rates will be given resource restrictions, or in this case also input restrictions in multiple product process.